So here we're taking a look at the polar equation r is equal to 1 plus 2 cosine theta. And we want to go ahead and look at the graph of this polar equation. And we want to start at theta is equal to 0. So when theta is equal to 0, you have cosine of 0. Cosine of 0 is 1. 2 times 1 is 2, and 1 plus 2 is 3. So you will have the point on the polar curve with polar coordinates r theta, where r is equal to 3 and theta is equal to 0. So when we start here, you can see that we start here at this point with polar coordinates 3, 0. And then in quadrant 1, cosine is positive. So we have positive values for cosine multiplied by 2, and we're adding 1. So then we get to theta is equal to pi over 2. Cosine of pi over 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. So we get this point with polar coordinates r theta, where r is 1 and theta is equal to pi over 2. And in quadrant 2, cosine is negative, but then you're adding 1 to it. So you're finding cosine values multiplying by 2 and adding 1. So as long as the sum is positive, you'll still have points that are traced along the terminal side of your angle. But when you get to theta is equal to 2 pi over 3, what happens? You need to find cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. 2 times negative 1/2 is negative 1. 1 plus negative 1 is 0. So when you get to theta is equal to 2 pi over 3, you get this point at the pole with coordinates 0, and the angle would be 2 pi over 3. So remember that, 2 pi over 3. And then when you go from theta is equal to 2 pi over 3 to theta is equal to pi, the r values will actually be negative. And when you get to theta is equal to pi, then cosine of pi is negative 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. So you have this point here with polar coordinates r theta, where r would be negative 1 and theta would be pi. So because r is negative 1, you have this point on the opposite ray from the terminal side of the angle. And then you keep going, and when you get to theta is equal to 4 pi over 3, what is the cosine of 4 pi over 3? Cosine of 4 pi over 3 is negative 1/2. 2 times negative 1/2 is negative 1. 1 plus negative 1 is 0. So you get this point at the pole with polar coordinates 0, 4 pi over 3. So you can see that the inner loop is bounded by the graph of our polar equation and the radial lines. Theta is equal to 2 pi over 3 and theta is equal to 4 pi over 3. Let me go back again. You can see here, this is where theta is equal to 2 pi over 3. The inner loop starts getting sketched. Here theta is equal to pi, and here theta is equal to 4 pi over 3. You can also use symmetry, and you could just find the area of the bottom half of the inner loop. If you do that, then your radial lines would be theta is equal to 2 pi over 3. Theta is equal to 2 pi over 3. And theta is equal to pi. So you have that option. Or you could also go from theta is equal to pi to theta is equal to 4 pi over 3. Of course, if you do that, you're only finding the area of half of the inner loop, and you'd have to multiply by 2. Or you could just go from 2 pi over 3 to 4 pi over 3. And on that entire interval, the r values are entirely non-positive. So our integration formula would be valid as long as you have r values that are either entirely non-positive or non-negative. And if you were to continue, we don't really need this, but just to complete the graph, if you go from theta is equal to 4 pi over 3 to theta is equal to 2 pi, you complete the Limacon.